Hello everyone, this is Dr. N.S. Srivatsan, Associate Professor of RMD Engineering College, AAA Department. In this video, we are going to discuss about EE8451 Linear Integrated Circuits and Applications, 4th semester EEE subjects, one of the topic, and the topic is IC fabrication process. Now, in this video, we are going to understand how the IC is prepared and what are the process involved in it, starting from the silicon ingot to the final IC chip, and what are the process that is involving in it. IC fabrication process involves many steps, but there are basic steps which will be followed respective of the IC, and there will be multiple process based on the complexity of the IC. For example, IC741 or a logic gate like AND gate or gate will go through one set of process compared to the most complicated ICs which will be used for communication purpose in modems or for general computing like the processor, Intel processor, which we use it for our laptop, desktop computers. So those ICs will also go through a number of processes which would be a repeat pattern of the basic steps. Now let's move on to the various steps involved in the construction of ICs. The first step is called crystal growth process. The second step is called epitaxial growth. The third step is called oxidation. And fourth step is photolithography. And fifth step is diffusion. The sixth step is called as isolation. Seventh step is called ion implantation. And eighth step is called aluminum metallization. And ninth step is called as assembly, processing and packaging, basically the packaging process. So these are the basic steps which will be repeated, and these processes would be there for all kinds of ICs. Now let's move on to the first process, which is called as a crystal growth process. So the crystal growth process itself has got about sub process, goes through 5 sub process, which is called as crystal growth and doping, and second step is called ingot trimming and grinding, and third step is called ingot slicing, and fourth step is called wafer polishing and etching, and fifth step is called fifth process in the crystal growth process is called as wafer cleaning. Basically we will be having a pure semiconductor which is silicon, and this silicon is melted in a quartz graphite crucible and melted at held at a temperature of 1690 Kelvin, because the melting point of silicon is around 1685 Kelvin. So the silicon is in the melted state, and the amount of doping or dopant added to the melt is properly controlled so that we have the right amount of doping is happening. After the silicon got melted, what happens is we will be using a seed crystal, which is a small perfect crystal of the same type, and which will be dipped into the melt, and the graphite crucible will be rotating in the clockwise direction, whereas the dip, or you can call it as a seed crystal, will be rotating in the anti-clockwise direction, and it is slowly moved away from the melt. So what happens is the melted silicon gets deposited in a cylindrical shape because it is rotating, and it forms a deposition of the pure semiconductor, a silicon, a shiny kind of material getting deposited in a cylindrical form as the dip or the seed is moved slowly away from the melt, and it forms the uh, drum like structure or a cylindrical structure, and that is called as the ingot. So, and it is allowed to cool, and after that the top layer and the bottom layer are cut. The ingot's top layer and bottom layer are cut, and after this the ingot trimming and grinding process takes over. Here what happens is the ingot will have rough surfaces. So to smoothen the rough surfaces, it is given a mechanical process of trimming where the top and the bottom are chopped off and the surface area are grinded to smoothness, because any uneven surfaces will create a wafer which will not be uniform and will create a improper circuit formulation. Okay, so because the surface needs to be very smooth and clean. The next step is called ingot slicing. So the ingot which is created, which is trimmed, which is grinded. Now the drum like structure is at the length of around 100 centimeter, and they'll have a diameter of 200 mm and up maximum up to 300 mm, or sliced. This is called as, once the ingot is sliced, it is called as wafer. So the ingot is sliced with the right dimension, with the right diameter, and this again, because the once the ingot is cut, it is called as a wafer. Now the wafer has also needs to go through this polishing, because the smoothness is very important. So it is going through, it will go through the process of polishing and etching, where uh, the surface is smoothened, and then it will go through wafer cleaning. So with the help of chemical process along with the water, it is cleansed. Now in the picture we can see there is a crucible, and you can see that silicon, pure silicon is melted, the graphite crucible, and a seed crystal is dipped in, and as slowly the seed crystal is dipped, moved away from the um, crucible, because it is rotated, one is rotated clockwise, the other one is rotated anti-clockwise. There is a deposition which is happening onto the seed crystal and forms a cylindrical shape which is called as an ingot, and which is again cut, and it is polished and also treated. So this ends our discussions in this crystal growth, and then we'll go to the main process. The second process in case of IC fabrication is epitaxial growth. So here in epitaxial growth, we will grow the material depending upon the kind of the transistor which you want to fabricate or the diode which you want to fabricate. So basically a layer, because the substrate on which the n plus layer will be grown, and the depth will be of few microns, and the area are properly chosen, and this epitaxial layer of n silicon is grown on the p type substrate. So this epitaxial layer is grown according to our requirement in terms of the device which you want to fabricate on the IC. The next step in this IC fabrication is the oxidation. And what happens is, once the epitaxial layer is grown and will be using the oxidation layer. Basically a silicon dioxide coating is done. There are two types of process. One is a dry process, the other one is a wet process. In case of dry process, the silicon and oxygen are sent at high temperature at the order of 950 degrees centigrade, 2150 degrees centigrade, and it gets deposited on the wafer or that on the wafer, and it forms a layer and forms the oxidation layer. The other process is called wet process, wherein the silicon and water is precisely added, and the silicon dioxide gets deposited and oxygen gets liberated. So it depends upon the fabrication process which you want to choose, whether it is want to use wet process or dry process. And the next process, we move on to the fourth step, which is called as a photolithography. Litho means stone, graphy means writing, and photo means light. So we use photons of light energy to write on the silicon crystal, and it forms the required circuit onto the silicon, the wafer. So what we do is, we already have the silicon wafer, and over which we already done the silicon dioxide coating. Then what we'll do is, we use a photosensitive resin or emulsion, photosensitive emulsion, a photoresist. We'll coat it over it, and then this will be a thin film actually, and we'll apply a mask wherever we don't want that to get exposed, depending upon our circuit, whether we want to create a transistor or a diode or a capacitor, whatever the kind of component which you want to create, both active and passive. So that will be given a photo mask. When ultraviolet light is made to incide upon it, so what happens is, the layers or areas which are exposed to ultraviolet radiations will get exposed, and masked regions will not get exposed. So, and then it can be etched and to form the required layers. So this is the aspect of photolithography. There is also electron lithography is also there, so where we use emissions, electron emissions, and to create that kind of formation also. If we use light, it is called photolithography. And next process is a diffusion, and because of the number of devices has to be fabricated, there should be proper interconnections, and of course there should be proper conductivity should be there, and with the help of a diffusion process, we'll be able to increase the amount of doping onto the system. Then we have the isolation process, which can be done with the p-n junction isolation, or you can use a dielectric isolation. A p-n junction isolation is a p-type and n-type material and back-to-back connection, and if there, it will not allow the current in either of the direction, in which case it will block, and hence the particular device, whether it want a transistor or diode, accordingly you can isolate, or you can use the silicon dioxide to isolate the particular device as such. So that can be done. Then you go through the ion implantation. So basically increases the conductivity, and with the help of required dopant, and the gas is sent, and basically it's a slow process because it is conducted at a vacuum, so the pressure will be very low, and it's a slow process, and it gets deposited, the dopant gets deposited on the layers, and it forms improves the conductivity between the regions. So this is about the ion implantation, which is process number 7. And we'll move on to the step 8, which is called as the metallization. The connections from one region to the other region. Suppose there is going to be a connection between a transistor and a resistor, transistor and a capacitor, transistor and a diode, whatever the device which we are, or JFET, whatever the device which you are trying to do, the connections will be established based on the metallization or metallic formation, or the connection being established because there is a silicon dioxide coating is there, which is isolating the devices. So we'll be using aluminum and aluminum will be because it is a low melting point, and of course it is lightweight, a good conductor, and gets deposited through uh, vacuum deposition. That it forms a low resistance contacts. Wherever you require the contacts will be established. So this forms the metallization, which creates the connections between the various devices. And final process is the assembly and packaging, and it depends upon the kind of package IC, how based on the requirement, based on the how the IC needs to be fit into according to the manufacturer's requirements. For example, for a particular application, how they want to mount. They want to go for a vertical mounting or horizontal mounting, and how many pins they require and what formation they have to have. So how many pins you need to have. So all those things will decide the assembly and packaging, which will in turn decides the size and area. All these things will go hand in hand, and it will be done with the capping, plastic capping or metallic capping will be done onto the wafer, which holds the circuit by default, and with the pins for the connection. So external connections for the pins is also created. So, and it is done in a different kinds of package. So where with this plug and play kind of stuff, where the IC forms the connections from the internal circuitry to the external circuitry, and so that will have connections, and also the packaging is done accordingly. So this is about the 9th step. So these are the basic steps which will be followed in the fabrication of IC, and this process might be repeated, and it may vary from one IC to the other IC. For example, a Intel processor might go through up to 900 to 1200 process. So it depends upon the kind of IC which you want to create, and the basic process remains same, but some of the process would be getting repeated. So this is a pictorial representation of what we have seen so far. First we get the pure silicons, pure semiconductor, and which we melt it, and we form a cylindrical kind of structure by means of Tucholsky process, and it is called as an ingot, and it is cut, and it is trimmed and grinded, and it is sliced, which is called as slicing, and which forms a wafer, and then it is oxidation is done, oxide coating is done. With the again this photoresist is applied, and photolithography is done onto it, where the required circuit is etched onto it, and goes through the improving the conductivity, where diffusion process and implantation, ion implantation process will increase the conductivity of the regions. And then the metallization is done, where the aluminum coating is created to create the contacts between the various devices, and finally we go for packaging. So this is how the IC is fabricated. And, so this is what the topic, which is IC fabrication process. I hope the video is useful to all of you, and we shall discuss, we shall meet in the next video, and thanks for watching.